Okay, student, in this session, we will discuss regarding a new topic, a new algorithm in this information security that can just help us to just change our plain text to the ciphertext, so that what basically why we require all this encryption process just to change our plain text to the ciphertext. So what is in ciphertext? This is such a form of encrypted text so that if the third party or any intruder wants to read your message in between, if you are just sending your message from from sender to receiver. So what is your purpose is regarding that you don't want your third party to read your message over here. So that is the case where you will be using your encryption process. Okay, so here what we will be doing that we will be doing one of the encryption process, that is the Vigenere process that will be having. So we have a method here whose name is Vigenere cipher technique. Vigenere cipher technique is there. So it was designed by. There are some points that I need to tell you that this particular algorithm was designed by a person, that is Blaise D. Vigenere. Okay, so this was the person who developed this particular algorithm. Okay, so this type of the algorithm is a polyalphabetic substitution technique. Substitution technique. Okay. So this particular algorithm, this is basically a substitution algorithm, that is a Vigenere cipher algorithm. But what type of a substitution algorithm is this? This is a polyalphabetic substitution technique. Okay, so it was designed by a person whose name was Blaise de Vigenere. So according to his name, we have just developed this particular algorithm, that is Vigenere cipher algorithm. Okay, now here encryption is done using. Encryption is done in this particular algorithm by using 26 by 26 matrix. Okay, so we usually use encryption method here by using a table here, that is 26 by 26 matrix over here. Okay, so this particular table is known as a Vigenere table. Okay, so that particular table is known as a Vigenere table. Okay. So that is used to find the ciphertext. So why we require this particular table? To find the ciphertext. Okay, so encryption is done here using 26 by 26 matrix, and that matrix is in the form of a table known as a Vigenere table. Okay, so why we require this Vigenere table? To find the cipher. Now just remember one thing, that if you are using this Vigenere cipher technique, so for that particular technique, what will happen? There are two methods. So first method is related with the table part. So in the first method, we will be using that Vigenere table, and second method is that method second, we will be implementing this particular algorithm without using the Vigenere table, without using Vigenere table. Okay, so Vigenere cipher was designed, again I just give you a brief view of this particular algorithm. So Vigenere cipher was designed by Blaise de Vigenere, that was the person who developed this particular algorithm. So according to the name of that person, this name has been given to this particular algorithm. Secondly, it is a polyalphabetic substitution technique. Okay, so this is one of the polyalphabetic substitution technique is there, and you have an encryption. You can do this encryption based on 26 by 26 matrix. So there are two methods to implement this particular Vigenere cipher technique. First method is using the Vigenere table, and another method is using the without using the Vigenere table. Okay, so we will start with this particular part, and the first method that we will be implementing, that is with the help of a Vigenere table. Okay, so here I am going to share my screen also with you in order to show that particular table with you. That is Vigenere table. So that table is basically 26 by 26 matrix is there. So that means 26 rows and 26 columns are there. Okay, so let's suppose we start with this particular part. Cipher technique. So here we will be implementing the first method, method 1, that is using Vigenere table. Vigenere, fine. So now let's suppose what will be there, like let's suppose we are having a plain text here, like give money. This is my plain text. So I am writing like this, give money. Okay, so that is the plain text that we are having here, give money. And another thing that we require while giving, that is a key. So now let's suppose my key is lock. My key is lock. Fine. So what first step I will do? I will write like this the plain text. Givemoney. Fine. Okay. Now what I will do? I will use this key again and again so that all the letters in my plain text should be covered by that particular. Okay, how this thing is possible? What I will do, I will just use this key to so that I just repeat the letters of the key so that the number of the letters in the plain text and key becomes equal. Okay, so what I will do, I will just allocate this key letters to this plain text and I will repeat all those letters. Like you can see here how many total letters are available in this particular plain text. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. And but how many letters that are present in the key? That is only 4 letters. Okay, so what I will do, I will write like this L-O-C-K, L-O-C-K, and again I am left with the last letter in the plain text, so I will write here N. Fine. So I will be writing like this L-O-C-K, L-O-C-K, and the last letter, that is N. So I need to repeat all those letters of the key so that the number of letters in the plain text and the key becomes equal. So that is the main rule. First rule, if we are using a Vigenere table over here. Okay. Now what I will do, I will just move towards, now I'm going to share my screen with you also. So you can just see. So you can see my screen here. Okay. So in this screen, we will just, I just enlarge this particular size. Okay. So this is my screen. Now this is the 26 by 26 matrix that I am talking about. Now this 26 by 26 matrix will consist of all the letters starting from the letter A to the letter Z. So we are having that 26 letters, that is all the alphabets starting with the A letter and the Z letter. Again on the row side also we are having all those letters starting with the A to the Z part. Now you can see this matrix table has been built by like this, like what it has done, that it is starting from the A, B, C, D till Z, and in the second row you can see A is not present and it has moved to the last line here. Okay, so it has moved to the last column here. So that is again in the third row, you can see that A and B both are not present, and we have moved both the letters to the last part, that is AB. If you are having the table with you, that's fine. Otherwise, you can just create your own table also like this. Okay, so similarly, we will be skipping all the remaining letters over here, or you can directly write like this A, B, C, D, E, F, G, H, I till the Z part. Okay, so if you see at the column side also, again A is missing, and from the second column we are starting with the letter B, and in the third column again we are skipping A and B, and we are starting with the letter C. And here if you have missed that A letter, so now where is that A letter? It is available at the last column. Okay, here you can see my cursor position, that is here. Again in the third column you can see that this is your C letter over here. So what you can see here, that both A and B are present in the last column of this particular last row of this particular column. Okay, so we represent all this column with a plain text, and we represent all these rows with a key part. Now, what is my combination? If you see the blackboard portion, so what combination I am having over here, that is G and L. So G belongs to the plain text. Where is your G alphabet? Here. You can see your G here. We are representing all these columns with a plain text, and we are representing all these rows with a key part. Now, what is my first letter here, plain text here, that is G. And what is the key value? That is L. So I just go to, this is my key element, L, and this is the G. This is the G part. So what answer you are getting here? That is R. Okay. So at the intersection of this row and column, what value you are getting? That is R. Okay. Now let's move to the next part, that is I and O. Now, what is I over here? If you have noted down this particular example, so I is your plain text. Again, I will move to the plain text. This is your I, and what is in your key? That is O. So you just move towards this part. That is O. This is your O part. Okay. So I move towards the I column. So I just move towards the I column. See here. This is W. Okay, so if you move towards upward, so this is I. Okay, and if you move towards this is O. So add, what is the number at the intersection point? What is the alphabet that is available? That is W. Okay, again we move to the next letter here. So we move to the next letter here, that is V and C. Now, what is the V? Where is V available in the plain text? Here. This is your V. Okay. And what is the next key letter? That is C. So this is your V part. Okay. And this is your C part. Now I move towards the V part. See here. So what alphabet you are getting here? That is X. This is the intersection of V and the C part. So what alphabet you are getting here? That is X. So this is the way. Similarly, what output you will be getting here? So like here we can just go towards each and every plain text character and the key value. Okay. So again, let do one more example, E and K. So this is your E. If I go towards the plain text, this is my E, and the next value is the K part. So this is your K part. This is the key. Now where is my E? Here. Okay. So this is the intersection. What alphabet we are getting towards the intersection? That is O. O and the E part is there. Okay. This is O and E. So this is the intersection. What you are getting here? O. Okay, so this is all about the Vigenere, this part here. So this is how with the help of a Vigenere we can use this particular technique of Vigenere table. So again, so what values we will be getting here? So I can give you this table afterwards and you can just check the value. So what ciphertext we will be getting here? So correspondingly to the plain text and to the key part, what ciphertext I will be getting here? So that is R, W, O, sorry, X is there, O, again, X, C, P, O, and in the last we are having that J. Okay, so this is your ciphertext here. Okay, so this is the ciphertext that is available to you. Okay, similarly for the decryption part, you can do the reverse process. For the decryption part, there could be case that you can be given with a particular cipher part and with the key value. Okay, so you are given with the cipher part and the key value, and you may ask to find the plain text here. Okay, so at that time also you can use this table concept. So let's suppose I am having the for the decryption part. Let's suppose what cipher I have received above, that is cipher value. For that cipher value, what I am having? R, W, X, O, X, C, P, O, and J. Okay, so again I will use that key here. So what was my key? L, O, C, K, L, O, C, K, and last alphabet with the L. Clear? And for the plain text, now we will find the plain text. Again, I will share my screen with you. So, okay, again, I am showing my screen with you like this. Okay. So if you are now see what I am having over here, that is the ciphertext will be available and the key value will be available to you. So no, so you can see here now what is my key value here? L. Where is my L? Here is my L. This is my key. All these letters on the row side, these are my keys. So I am having the letter L here. Okay. And what is the cipher value I am available with? That is R. So here you can see this R. Okay. This is your L. This one. This one is your L. And correspondingly, you can see that each alphabet is occurrence of each alphabet is once. Either you are going towards a row, either you are going towards a column side. So you are having the value R, and so correspondingly to this R, you see what element you are getting at the plain text, that is G. So this was your first alphabet of your this plain text. So that was G. Okay. Again, I repeat. Now, what cipher again you are having, that is W. This is your W. So I will move towards the I will move towards the key part. So you can see here, again my key is O. Okay, my key is O and I will now get the value of W. Okay, so that is the cipher part. This is my O, this is my key, and here is my ciphertext, that is W. Now what corresponding plain text value I am getting here? That is I. So this was my next letter, that is I. G, I. Okay. Again, what was the key letter here? Now I'm just doing the process of this decryption part. Now what alphabet I am getting here? In the key part, that is C. Lock and up, L is there, O is there, and now we are moving towards the C part. C is there. Now C, and what is the value of the ciphertext? That is X. This is your X part here. And what corresponding letter you are having here? That is V. What corresponding letter you are having here? That is V here. Okay. So this is how you can just convert all your letters. Okay. So in the decryption part, what main thing you require, you move towards the key part. Whatever the key elements you are having, you just first search that key element, and whatever the corresponding cipher value is given to that in that particular key element. So you just locate that particular cipher element in that particular row. Okay, and correspondingly to the upside, you can see what plain text, what alphabet we are getting. So that alphabet will be your plain text. Okay. So this was all about that particular this cipher, Vigenere cipher technique. And now what value you will be getting here? So what plain text we will be getting here? So after intersection, using the concept of this table, so we will be getting G, I, B, E, N, O, N, C, 1. This will be your cipher text, plain text value. Fine. So Vigenere table will be maybe available to you, or if it is not available, you can just immediately make that table. So I have shown you the method by which you can make your own you can make your own table instantly. Okay. So this was the first method that we have done using the Vigenere cipher technique. Now the next method is that without the table. Okay. So the next method is that now that we will discuss the next method, that is without the table. So sometimes in exams that is mentioned over here that you have to use the table. So at that time you can just make your own table over there. Okay. So but with the same technique that Vigenere table is using, or if it is being mentioned that you don't have to use a table, so at that case you can use this particular. Okay. So we are having like this. Method second, and that is without Vigenere table. Okay, so that is without Vigenere table. Now there is another technique that how we can use this. So for this particular part, we have two formulas over here. One is for the encryption part. So what formula we will be using here? That is CI, or we can represent this with the encryption part EI equal to PI plus KI mod 26. That is a formula. Okay. Pi plus Ki mod 26. And whatever the addition, after addition we are getting, and we are just taking the modulus for the same. Okay. Again, for the decryption part, what formula we are having here? We can just represent this decryption part, that is Di equal to EI. So where we were getting that EI value here. Okay, or we can write like this CI. Okay, EI or CI. Okay, minus P. So what is K here? P is the plain text, K is the key, and E is the encrypted. Again, for the decryption part, what we are having? Encrypted data is there, or ciphertext is there, minus KI, and that is mod 26. Mod 26. Fine. Now let's suppose we will start with the example part, and here I am writing like this, plain text. What is my plain text? That she is listening. Okay, she is listening. This is my plain text. Now, what key I am using here? That is Pascal. What key I am using? That is Pascal. Fine. Now, I will move towards the steps here. So here, let's suppose my key stream I will be using here. Okay. So now I will just, if you remember the key streams that we have mentioned, we were representing all those alphabets starting with the A, 0, B, 1, C, 2. Okay. So D as a D, 3, E, 4. So many till Z. So these were the different, we were having this particular, this key streams value over here for each and every alphabet. Okay, so what about this master? This is your key. I will just change it to the key stream. So what key I will be using, that is 15. That P is representing with a 15, 0. And next we have S that we represent with 18. Okay, and next is 2, 0, and again 11. Okay, so these are the key streams values that we have used for this particular key path. Okay, so that is 15, 0, 18, 2, 0, 11. So where we have got this value from this particular path. So as you know that we can start with the letter A, and we have allocated that 0 value to the same. Okay, so this is how we have used that key string here. And again, the process will remain the same as we have done using that Vigenere table, that we will be repeating that key value over here. Okay, so what we will doing, we will be repeating the key elements over here unless it covers all the elements of the plain text. So what we will do here, now let's suppose this is our plain text, and here we can represent that plain text, that is S H T. What was my plain text? She is listening. I S L I S T E N I N. Last we are having that G. So this was your plain text. She is listening. Now what is the P's value over here? As we have converted a key to the string part, again we will convert a plain text also. So just allocate all those values. Like for the S part, we are having 18. H we are having 7, 4, 8, 18, 11, 8, 19, 4, 13, 8, 13, and 6. Okay, so these are the value that we have given to all those alphabets, and from where we have got this value, starting with the A letter to the Z letter, and we have allocated all this. Right? Now, next is the key string. So now we will be representing the key string here. So what is the key string? Like 15, 0. This is the key string. 18, 2, 0, 11. Again, I will repeat this two. 15, 0, 18, 2, 0, 11. Okay, again, what value I am giving? 15, 0. Okay, so that is the cipher text value. Now, we will add both these values, and we can just get that ciphertext value. Now, what is 18 plus 15 here? So if we just calculate this part, 18 plus 15, so what value we will be getting here? That is 33. Okay, but now total elements in my alphabets are, that is total, how many elements we are having, that is 26. So what we will do, if my number exceeds from that 26, I just minus this number, that is 26, from this 33. Okay, so what value we will be getting here? So that is a 7 value we will be getting here. What answer we will be getting? 7. So we will be writing like 7. This will be done only in that particular case if the sum of your addition part exceeds the value of 26. Okay, so if it is exceeding the value of 26, then you have to subtract that 26 from the total sum, like this. Otherwise, you can write like same. So 4 plus 18, that is 22. Again, this is 10, this is 18, this is 22. 15 plus 8, that is 23. 18 is there. Then we have that 19 plus 18. So obviously, again, this will be exceeding all those values. So we will subtract that particular number from there and we will be getting the value 11. Then we have 6, 13 and 19. Again, what 15 plus 13? So that is, we are again having that 28 value here. Okay, so that 28 value will be getting and we will subtract that 26 from it. So what answer we will be getting here, that is 2. Okay, and lastly we are having that 6. Okay, so this is your ciphertext value. This will be your ciphertext values. Clear? Again, now we will, according to these numbers, we will now get the particular alphabets here. So how we can get that C? So ciphertext will be how we are representing the 7 letters. So if you see this particular table, so what values you will be representing here? That is the H part. Okay, so this is your H. This is your H. What alphabet come at the number 22? That is W. Okay, and we are having K, S, W, X, S, L, G, N, T, C, G. Okay, so these are all the values that we will be using. Okay, so what we have done, I just again repeated. This is your plain text. First of all, for any type of encryption, 2 things will be given to you. One is your plain text and another one is your, that is a key value. So what you have done, this is your key value. You just changed the value of this particular key value to the string part, that is a numeric value. So starting from the 0 part till the Z, that is 25 will be the last element that you will be having. And you just convert all those alphabets to the fine. Now, this is your plain text. She is listening. You just change this particular alphabet value to the numeric value like this. Again, we have a key stream here. So you can use a key stream 15, 0, 18, 2, 0 till the end. Add all those numbers. Just remember one thing. If your result of the addition is greater than 26, okay, so then you have to just you have to subtract that 26 from that particular time. Okay, so that particular thing you will be subtracting from that number. So what answer, like in this particular case is there, and one case was this and one case was this. Okay, so here what, how these values have come, because we have subtracted the 26 value. Okay, so here after that, whatever the corresponding alphabet we are having for each numeric value, we can just type that. So this is my ciphertext. Okay, so this is my ciphertext here. Okay, again, if I need to just change my this ciphertext value, so we can again, what we will do, we will have that now let's suppose you are given with the ciphertext part and you are given with the key part. So you are being asked to just calculate the plain text value. Okay, so again, what you will do, this will be your ciphertext. You convert it to this particular C value and use that, again, use that key value to it. So what key value you are having here? Okay, so this is the portion for the decryption part. Okay, so for the decryption part, again, we will use that key text value that we will be having, and we will just convert this all this value of the ciphertext to the key value. Fine. So this was all about the ciphertext part, and here you can see that how we can get all those values. So this is for the encryption part. For the decryption part, we can just again add that key value to the plain text, and whatever the result we will be getting, if we see that if our result is greater than that of that particular value of 25, so what we will do, we will subtract that particular 26. We will add that if we get the answer in the negative form, we will be adding that 26 value to that particular value. Okay, so we will be adding that particular value to the 26 number. Fine. So this was all about Vigenere cipher techniques. Okay, now we have done all the substitution techniques so far. So we have done so many encryption algorithms based on this substitution techniques. Like Hill cipher was there, Vigenere is there, okay, Playfair was there. So all this was the substitution. So what basic methodology that we follow in substitution technique, that we are just substituting a particular alphabet with another alphabet. Fine. Now, the next term that we will be going to start with is that is the transposition technique. Okay. So there is a term known as transposition technique. So transposition technique says that rearrangement of the letters. That is rearrangement of the letters. Rearrangement of letters. Okay, so how we represent a word transposition, that we follow different permutation techniques over there. So just we are having that rearrangement of the character position will be there. There will be no substitution or there will be no replacement of any letter. So what we are doing, if we are given with a particular plain text, we are just rearranging all its letters over here. That is the main purpose of this transposition. Fine. So we can apply all those this rearrangement of the character, and we will apply some of the permutation technique on the plain text. Okay. So here you can start with like this. Like transposition can be done without the key also and with the key also. So how we can do this transposition technique? That is without key. So that is without key. And second method is with key. Okay. So without key, what will happen that we are not given with any type of a key over here. Now let's suppose we start with this particular part. We will discuss both the methods one by one. So here without key method, what it says that we are having, let's suppose we are having that plain text. Hello. How are you? How are you? Okay, so how we are not given with any type of a key here. So how I will write all those letters like this: H, E, L, L, O. Okay, then H, O, W, R. How, this is hello, how, R, A, R, E. Okay, and that is Y, O. Okay, so I am writing all these elements diagonally. Okay, so these are the diagonal elements by which I am writing all these elements diagonally. So this is the case where I am not giving with any type of a key here. No, what will happen here? So you can see like this. Okay. So you are given with this particular part, that is plain text. Hello, how are you? So here you are given with HELLO, how, HOW, okay. So this is hello, how are you? Fine. So here what ciphertext that we are getting? Like this. So first we will write the first row over here, and after that we will write the second row. That is HLOO Fine. This is your first row that you have written. Next we are having ELHWRY. This is your second. So by combining both these things, we are getting the ciphertext. Okay, so this is the first method where you are not given with any type of a key. So you have just rearranged all the elements of your plain text. So how you have rearranged all those elements? By just writing them all in the diagonal. Okay. Now let's suppose I am given with a particular key. Now the next method would be with the help of a key. Okay. So with the help of a key, what will happen? Let's suppose your key value is, you are given with the key 4, 5, 3, 1, 2. Okay. So how you can write like this? This is your 4, 5, 3, 1, 2. This is the key you are given. Now I will be using the same plain text here. That is hello, how are you? So how I will write like this? H E L L O, hello, how? H O W A R E. A, how? This is how. H O W R A R E U Y O U. Now we are left with one part here, so we have to we can just skip that particular part. Okay, so we don't have to substitute anything here. So we will just skip that particular part as an empty portion. Okay, so this is with the help of a key. You have been given with this particular key. So by using the same plain text only, you have written all the elements of the plain text like this. Okay. Now when I will get the ciphertext, what I will do, I will just arrange all those elements in a ascending way. Okay, so in a ascending way, what you will be getting first I will write the first column number. So that is LAU. LAU. Now what is the second? OR. OR. Third, then we are having third LWO. Then we have fourth HHE. Okay. Then we have the fifth part over here. So that is EO. This is your ciphertext. This will be your ciphertext. Okay. So LAU was the first element, OR was the second, LWO was the third, HHE was the fourth, and this was the. Okay. So this is the with the help of a key how you can write like this. Okay. Is it fine? So this was all about the two methods that we can use in case of a transposition techniques. So in transposition techniques, basically we do the rearrangement of the letters. So that rearrangement of the letters is with the key and without the key. Okay, so without the key, you have to just write all those elements in the diagonal way, and with the key, you will be given with some key value, and you just adjust all those letters among that key values, and after that, you have to write all those elements in the center. Fine. Now, there is another method of this transposition technique, that is a rail fence method. This is one of the important methods that we are having. That is a rail fence method. So another technique that we are having here, that is a rail fence method. So this is rail fence. So rail fence technique says that now there will be a new parameter here known as a depth. Obviously, a plain text will be given to you, and another parameter that will be given to you, that is depth. Okay, so depth will tell you that how many rows you can have for a particular this plain text. Okay, so depth will be the new parameter that will tell you that how many rows you will be getting for that particular plain text values that you are having. Now let's suppose my plain text value is good morning. Okay, it is good morning. Fine. Now the next thing is the depth is 2. Now let's suppose I have given my depth value as 2. So what value of that depth I have given? That is 2. Okay. So how that means this depth will tell me the total rows that I will be following for this particular case. So in that row 1, I will be having row 1 and second one is the row 2. That is all depends on the depth value that I will be given. Okay. So how I can write like this? Good. Now the first part is the good. So I will fill it like this. GOOD. Okay. And then we have MORNING. Now we are left with one empty element. So here we have to fill this also this particular element and we will add that X part. Okay. So this is the X part we are having. Now how I can conclude to my this ciphertext part here? So how I will be getting my ciphertext here? Like this, I will be writing ciphertext GOMRIGON and last will be your X. Last will be your Excel. This is how you are representing a rule. So same method we have done in the case of this particular the same method we have done in the keyless case also, but in that particular case we haven't defined the depth part. But whenever you will get that rail fence part, so in that rail fence you will be given with a particular parameter, that is a depth parameter, and you will be given with the particular value points. Okay, so according to the depth value you can include that many rows in your particular plain text file. Okay, so okay, let's suppose we are given with this particular ciphertext. Now this was the part of your encryption part. Okay, so this is your encryption part that you were representing. Now let's suppose I am given with this particular part over here, and the ciphertext over here, and I am being asked to get the plain text value over here. So first of all, I will find the total length for this particular part. So what is my total length? It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This is my total length. Okay, so total length will be 12 over here. And let's suppose I will be also given with the depth part. Okay, so my depth part value is 2. I will divide this length by 2. So what value will be getting? That is the 6 part. Now say this 6 part will tell you that how we can that plain text value that I will be getting over this. So you can see that the particular value. Okay, so this is G. Okay, and the another part that you will be getting over here is that G 1, 2, 3, 4, 5, 6. Okay, so 6 will be the total. This is a G part. So first alphabet of your plain text will be G, and you will move towards a 6th letter. 1, 2, 3, 4, 5, 6. This is your O. So you will be getting O. Okay. Again, we are having this second letter here. It is O, and we will move towards the next one. 1, 2, 3, 4, 5, 6. So that is. Okay. Again, next element will be M. This will be your M, and I will move towards the 6th element. 1, 2, 3, 4, 5, 6. This will be my letter. Here, M is there, R. Now I am writing R, and from this particular R, I will move to the 6th element. How I have calculated the 6th element? By getting the total length and divided by the depth value. So what depth value I am given with? That is 2. So R is here 1, 2, 3, 4, 5, 6. N. Okay. Then we are having I. I is here against the 6th element 1, 2, 3, 4, 5, 6. Okay. Then is G. G. 1, 2, 3, 4, 5, 6. That is the X element. That will be the, we can include it as a last element. Okay. So this was all about that we need to define regarding this transposition techniques. Now, there is another method. So total, we have done keyless method, keyed method, rail fence method. Now the fourth method that we are doing here for this transposition technique is the columnar method. So that is the columnar transposition. Okay, so for the columnar method, what rule we have to say that we require a table. Okay, so here we can like we require a table of 5 by 5 matrix here. Okay, so let's suppose preferably we use the 5 by 5 matrix table here, and for this particular columnar part, what we will be doing here that okay. So let's suppose I am given with this particular 5 by 5 matrix. So let's suppose now here what we will do that we will give importance to the columns over here. Okay. So what we will be doing that we will be just having importance to that particular column part here. So as we say that columnar transposition, so we don't give preference to the rows part, we give preference to the column part. Again, I will be given with the plain text and the key value here. So first of all, what I will do, I will make a 5 by 5 matrix like this. 1, 2, 3, 4. Okay. So this is 1, 2, 3, 4, 5. Again 1, 2, 3, 4 and 5. Okay. Now let's suppose my plain text is that is 5 minutes engineering. Okay. So I am, this is my plain text, anything that you can write over here. So what I will do, and there will be key value that will be given to you, that is 4, 3, 5, 1, 2. Okay, let's suppose this is a key value that is being given to you. Okay, so I just, instead of 5, I just write 4. 4 minutes engineering. Okay, so what I will do here, I will just fill up this matrix part with all the elements of this particular plain text. So I am writing like this F O U R. Okay, then is minutes M I N U T E S, minutes engineering E N G I N E E R I N G, engineering. Okay, so this is how we have filled all these elements. Okay, now what I will do, I am given with this particular key part 4, 3, 5, 1, 2. So I will see that I will include the rows column parts over here. I will not go to the rows part. I will go to the column. Now what are the different elements that are available in the column part? So that is, so I will first, this is my key value 4, 3, 5, 1, 2. I will go to the first column, that is 4, like this. So what is my value over here? That is R, T, G, R. This is my fourth column. Then we have third column here. So what is that third column? U, U, N, E. U, U, N, E. This is my third column. Then I am having fifth column. So what are the values? M, E, I, R. That is my fifth column. 4, 3, 5, 1, 2 is the key. That is 5. Then I am having first value. That is F, I, S, N, N. This is the first. And last one is the 2. So I am writing like this, O N E E G. O N E E G. This is your second one. Okay, so this complete will be your ciphertext. So with the help of a key, what you have to done, you have to give importance to the column part, and whatever is the column part, whatever the elements that you are having in your column part, just write that parts in a particular sequence. Okay, so this is a columnar transposition. Okay, so if you are using a 5 by 5 matrix, so then it is mandatory that your key value should also have that 5 elements over there. Okay, so because every time if you are giving a key value with the 5 elements, so it's required that you include a 5 by 5 matrix. Okay, so this is how we can use this columnar transposition. Clear? Now, the last transposition method that we have to do is so this was the fourth technique, and the last technique is the double columnar transposition. Last technique is the double columnar transposition. Double transposition. Or we simply replace double transposition. Now, let's suppose I am again given with some particular row size and the column size. Now, in this particular method, you will be given with the column size also and the row size also. In the case of a previous column expression transposition, that was mandatory that you have to include 5 by 5 matrix, and your key should be also with the 5 elements. Okay, so here what's let's suppose we are having a plain text value here, that is x at x. Okay, so that is just again like this, a attack x, a attack x at x don x. So anything that I can write like this, that is a plain text, attack x at x don x. Now let's suppose this is my plain text that I am being given with, that is attack x at x don x. Now what I will do, let's suppose I am given with a column C1, C2 and C3. These are the 3 columns that I have been given with, and we are having 5 rows here. Row 1, row 2, row 3, row 4 and row 5. 1, 2, 3, 4, 5. Okay, now I fill up this particular matrix with my plain text. So how I can write like this? A, T, T, A, C, T. X, A, T, X, D, A, W, and okay. So these are the value that you are being given. You will be given with the plain text and the number of rows and the column. Fine. Now, what I will do, suppose you are given with the permutation part, that you have to permutate your column like this. Like we are having column like 1, 2, 3, and we will permutate as 1, 3, 2. Okay, and rows, how we will permutate our rows like this. How many rows we are having? 1, 2, 3, 4, and 5, and we will change it to 3, 5, 1, 4, 2. Now I am going to first change this table as a first column wise. Again, I will change this particular matrix table into this particular column. So what according to this rule says that 1 will remain the same. Okay, now the new table that we will be getting after doing this columnar transposition. So C1 will remain the same. A, X, X, W. Because it is saying that one should remain the same. And now, but in the second part, we can get the third column. So what is the third column that values for the third column that we are getting here? That is T, K, T, A, X. Right? T, K, T, A, X. This third column row will now become the second column. And second column will become the third column, like this, according to the requirement. That my like I have changed my second column with the values of third column, and now I am changing the third column with the values of the second column. So that is T, C, A, D, N. Column 2. Now this is your new matrix table after performing this type of a columnar transposition. Fine. So this is your columnar transposition. Here. Now, second, again, what is the name of my technique is double transposition. This is a fifth technique that we are doing in the case of the transposition. So one transposition we have done according to this column part. Now we will perform the second transposition according to the row form. But this particular formula will now work on this particular matrix table, because this is my new matrix table. We will not include this particular matrix table. I will now include minus table. Okay. So again, we are having row 1, row 2, row 3, row 4, and row 5. Okay. So we are having all these rows over here. So let's change it to the different values. So I just simply tell you that how we can perform this particular part like this. So we are having only 3 columns, only 1, 2. This is your row 1. Let's suppose the value that we are getting row 1, row 2, row 3, row 4. Okay, and last one will be your row 5. Now, what it says that in the first row include the third row. In the first row include the third row. Now, what are my elements? That is XT. X, T, A. This will be my first row. I have done one calculation. Second row should include fifth row element. So that is a WXN. WX. Third row must include first row element. So third row, I am on the third row, but its member should be first row element. A, T, T. Okay. Fourth row must include fourth row. The same only I have done on the same combination. So I will writing like this X, A, B. Okay. And fifth row includes the second element. So fifth row, this is my fifth row, but it will include my second row. That is A, K, C. Okay. So A, K, C will be that. So this is how we have performed that double transposition over here. So one is done being at the column part, and another one will be at the row part. Okay, so this is how we are doing this transposition technique. Secondly, just remember one thing: we cannot repeat any row or column, because what we are doing in the transposition technique, we are just rearranging all that elements. So if we repeat all those elements, what will happen? So repetition of characters will be there. That is not required, because what we want, if we are having total 10 characters, so we have to do all those rearrangement according to the 10 characters. So we cannot have duplicacy of that character at that time. Fine. So this was all about the transposition techniques. So we have done with all this substitution techniques and the transposition techniques. And in the next lecture, we will be going to start with the new method of that is DS algorithm is also there. So some different algorithms that we will be performing in the next session. Okay. So thank you for patiently listening.